The first step in programming any project is to figure out what all the inputs and outputs are that are available, and to try and make some sense of which ones go together. I've already moved all of the inputs and outputs that I want to use over into the Click programming software and labeled them. You can see them here, and I'll bring up in Factory I/O the way they're set up and the way they're connected to the PLC. So we're looking at outputs on the Y's, so you'll see they just match. Conveyor 1, load 1, unload, transfer right. So we've got a bunch of stuff here, and the question becomes, what is this? You'll notice I'm not using the counter for anything, although I could. Some of the things are pretty obvious. The start light, reset light, and stop light, those are just the lights that backlight the buttons on the control, so that's easy. Conveyor 1 is this far conveyor here. The one on the right is actually conveyor 2, which is over, let's see, on looks like Y6. Now some of these outputs I'm not going to use. For example, transfer right, there's actually these transfer conveyors that have the orange strips on them. And transfer right means that those arms come up and there's belts on them, and it will move the pallets in the direction off of the conveyor, off to the, well, in this view, the right, but from the pallet's perspective to the left, and just throw them off the end, and that's not something I want. In any transfer here, I will never want to take a pallet from conveyor 1 and move it over to conveyor 2, so I'll never transfer to the right. A pallet on conveyor 1 needs to be merged with the pallet stream from conveyor 2 and put onto this exit conveyor. By the way, the exit conveyor, you can only see a bit of it. The output on Y11 is the motor for the exit conveyor, and you can see it just to the right of the control box. The transfer left, however, for both transfer conveyors, because notice the transfer conveyors, there's actually two of them. One of them sandwiched in between conveyor 1 and the exit conveyor. The other one is at the end of conveyor 2. But these transfer conveyors, I'll need to move both left. So, for example, if I have something coming in from conveyor 2, I'll use the transfer conveyors to move it over to just in front of the exit conveyor and then go from there. So transfer left 1 and transfer left 2 is important to me. And the 1 and the 2 just correspond to the same as the conveyor 1 and 2. And I'll use that terminology throughout. Other than that, that's about all I really need except for load. Now unload, I don't know why they call it unload, because really what it does is make the transfer conveyor rollers run backwards. So I guess you could say you're unloading the transfer conveyor, and that's fine. It's just moving it back, and I'll never do that. I want to bring pallets onto these transfer conveyors from conveyor 1 and 2, and so I will only use load 1 and load 2. So there's a bunch of things here that I'm not going to use. Let's see, if I were to I guess I could change an initial value or something, or maybe I can highlight the ones I won't use so you can see them. It won't let me highlight multiple things at once. You'll just see me use them. So those are the outputs that are of interest. And one thing I'm going to do from the very beginning is I'm simply going to turn on the exit conveyor. I just want it to run continuously. I wouldn't have to do that, but that's what I want to do, so that's what I'm going to do. As far as inputs go, of course I can't use the actual X inputs because this is being simulated, and there's no way that I've found yet to have Factory I/O overwrite the actual input values on the PLC. So there's a few sensors that I want to use. At entry 1 is this little sensor kind of tucked away right back here. I don't know if I can, I'm not highlighting it. That's a stop, but it's right behind that stop. And it's just a beam, it's a reflective beam, and when a pallet's there it reflects back, and so this particular bit C1 would be true. At entry 2 is similar, and you can actually see that one a lot easier. It's right here, I've got it highlighted now. And again, it's a beam, and as soon as there's a pallet that comes to the end of conveyor 2, then that beam is tripped, and we know something's there. At transfer 2, let me address it first. It's actually a sensor right here. And so what happens is when a pallet comes and finally stops at the hard stops here in the transfer conveyor, that sensor comes on. At transfer 1 is a little bit different. It's off to the side here. You couldn't put this in front of the transfer conveyor because the pallets have to move past on the exit conveyor, but you can sense the pallets from the side. So there's another sensor here to tell us that we've got something in the transfer conveyor. At exit is this sensor right over here, and it just senses when a pallet is coming into the exit conveyor. The start, reset, stop, and emergency stop are all buttons on the control panel. And then the auto switch I'm not going to use, but it's the auto manual mode. We'll learn how to use auto manual mode a little bit later. Now I've already defined 3 different bits, and let me explain what I'm thinking here. The basic problem here is merging 2 streams. I mean, if we didn't have conveyor 2, all we really have to do is turn on conveyor 1 and the exit conveyor and the transfer conveyor 1, just let product roll through, or pallets roll through. The problem is we have to somehow figure out how to stop conveyor 1 and merge the pallets from conveyor 2. So we've got to make a decision about that, how that will happen. And what I'd really like to do is just have maximum throughput, just have pallets running through here as quickly as possible. And so if there's something available from conveyor 2, I want to send it on. If there's something available from conveyor 1, I want to send it on. But what if, I mean, it's pretty easy. If there's nothing available in conveyor 1, I just send through whatever's coming through in conveyor 2, and vice versa. But what about the case where we have something available from both conveyor 1 and 2? What would I do then? Well, to make it fair, you know, I mean, it's possible that there could be continuously something that keeps appearing where I've got pallets just waiting to be merged together, and so I've got to make a decision. So what I've done is I've got a bit here that I've defined. I call it toSelected, and the idea is that if this bit is true, then the next pallet that's going to be serviced will come from conveyor 2. If it's false, then the next pallet that will be serviced will come from conveyor 1. So that's just a bit so I can kind of toggle it back and forth and keep track of who went last. Now, it's also useful to know, okay, so if I'm working on something, I can't tell the difference between a pallet that's come from conveyor 1 or conveyor 2 if it's at transfer 1. In other words, if it's over here on this transfer conveyor and this transfer 1 sensor senses the pallet, the PLC is too dumb, it doesn't see anything, so it doesn't have any idea whether this pallet ultimately came from conveyor 1 or conveyor 2. It doesn't remember that. So what I've done here is I've included a servicing 1 and servicing 2 so I can remember, okay, this pallet I've got in this system, I don't care if it's over at the transfer conveyor 2 or 1. Obviously, if it's in 2, then it's coming from conveyor 2. But I don't care where it came from. I'm going to remember where it came from. So in other words, I'm servicing a pallet that came. Now I could have set this up. I purposely set it up differently than this bit because I could have set this up where it's either true or false, and true would be servicing from 1, false would be servicing from 2, or vice versa. I can define that however I want. It's just up to me to use that bit consistently and set it when it needs to be set and reset it or turn it off when it needs to be turned off. So that's a lot to consider. How will I make an algorithm to, you know, make these bits work and basically do part tracking? That's really what we're getting into here. Is you got to realize that PLCs are blind and they're dumb. Okay, unless you make them remember something, they won't. And so just because a pallet comes down conveyor 1 and trips this sensor here at entry 1 and then goes into the transfer conveyor, the PLC couldn't care less where it came from. All it can do is respond to inputs and set outputs. And so if we want to remember something, then we have to make memory bits to do that and make them happen when they should. So my general idea here, there's a couple of ideas to be clear. At first I was thinking that I would let pallets just come to these beams at entry 1 and at entry 2, and then I realized that it would be more time efficient to go ahead and load up transfer conveyor 2. So go ahead and really use this sensor at transfer conveyor 2, similar to how I would use at entry 1 over here, to indicate that something has been given to me from that conveyor, conveyor 1 or conveyor 2, that's ready to be processed. Now obviously the process for a pallet coming from conveyor 1 is different from the process for conveyor 2. And you know, what I'd have to do with conveyor 1 is just simply turn conveyor 1 on, turn the transfer conveyor on, and just wait until the pallet comes through and the exit sensor goes from high to low, and then I know I've processed a pallet from conveyor 1. But for conveyor 2, the way I have to process it is I've got to turn on the transfer conveyors, get it over to transfer conveyor 1, and then send it on. So in the interest of time, my general strategy will be to simply turn on the conveyor until the at entry 1 beam is tripped, or until, well, not or, but also turn on conveyor 2 and in fact this load transfer conveyor 2 until at transfer 2 is true. So that's my general approach to this. Now, along the way, I'll have to remember that steps have been taken. What do I mean by that? Well, there's a sequence of events that have to happen. Just because I've got a pallet, say, in fact, here, maybe I can grab one quickly. Just because I have a pallet, now let's see, let me grab one. So hopefully it'll give me a pallet intersection. But just because I have a pallet at transfer conveyor 2, we'll grab one and see if we can. I pulled it through the conveyor, pull it out. I guess a top view would have been a little better here, but there we go. Grab a hold of it and pull it forward. There we go. So roughly, hopefully it doesn't end up this bad on the transfer conveyor. So just because I have a pallet here, it's not as easy as, just telling the PLC, okay, take it and put it on the exit conveyor. No, I have to make that happen. There's a sequence of steps that have to occur to get this over. Number one, I got to turn on these transfer rollers. And so I've got to turn it on and wait until the pallet manages to come over to transfer conveyor 1, and I'm afraid it's going to... No, it didn't fall on the floor. There we go. Of course, it's hard for the system to know what I'm trying to do in 3D when I'm only really moving a mouse in 2D. So I've got to get the pallet over to transfer conveyor 1, and after that, I got to shut off these transfer conveyors, turn on the load conveyor, or the load on the transfer, and that way the pallet goes on, hopefully not through the conveyor like that. See, so there's a sequence of events, right? I got to move the pallet over and then get it off. So remembering where I'm at in that sequence will be really important. So I'm going to show you something called finish flags. Now, usually a finish flag is more used when a whole process is finished, but a finish flag is also correct to say you could use a finish flag to remember that events have occurred. And really, you've used finish flags in a sense, because the seal-in circuit that I've already taught you is a circuit that remembers things, right? I mean, that's what it is. As a matter of fact, why don't we just begin simply? Let's start with the buttons. We've got a start, stop, and reset button. I'm not going to use the reset, I don't believe, but let me set up a program to just activate the buttons. We'll make it do something simple. Now, I could make a seal-in circuit. Now, I'll go ahead and do that, but I'm going to change it. So the classic seal-in circuit looks something like this. We'll get a start button that is normally open, put it in place. The stop button's normally closed, no problem. I think that's on either C7 or C8. It must be C8. Okay, and we'll make something come on and then or around the start button in order to keep it on. This is the classic seal-in circuit, right? So we go over here. What are we going to seal in? Well, a logical thing to seal in is just the start lamp. So I could go and grab the start light or lamp that illuminates the push button and use that as my seal-in. As a matter of fact, I could simply use that output Y12. Let's try Y12. In order to remember that I'm in start mode. And then I could use an instruction like this to determine whether or not I'm in a run mode, right? Whether I've hit cycle start. That's really what this button's typically called, is cycle start. And the reason it's called cycle start is because PLCs are used so often for performing a cycle or performing a sequence. So knowing how to make a sequence work is actually really important, because it's a majority of what PLCs do. Now, this is one way to set it up, and this would allow the start light to come on and us to know we're in run mode. I could do something with that. For example, I could say, well, when Y12 is true, whoops, sorry, I usually use a Dvorak layout, and, well, one more time. There we go. Sometimes it translates well and sometimes it doesn't into this virtual machine. But anyway, I could make that drive something. For example, I don't really want the exit conveyor to run unless I've turned the machine on and I'm making it run. So the exit conveyor could simply be driven off of the start light, because the start light's on, indicating that the user's pressed the start button, the cycle start, and so we want the exit conveyor to run. Now, there's other things we could do, right? This could be a condition for other things actually happening, because you wouldn't want the conveyor 1 and 2 to run unless this was true. But we'll add that in perhaps at the very ending. For right now, I've got a cycle start, a cycle stop, but there's another way to do this, and I'm going to change the seal-in circuit because I'm going to use a different technique throughout most of this program, and I want you to understand how it works. Since you understand the seal-in circuit, what I'm going to do is use something that will do the same thing. Okay? Instead of using outputs, which can turn, or this instruction can turn an output on or off, I'm going to use set and reset. Now the nice thing about the set and reset commands, it'll be the same address. Oh drat, hang on. There. The set command can only turn outputs on, the reset can only turn outputs off. So actually, it's as simple as writing this. This will actually, when I press the start button, it'll turn on Y12 and it will leave it on. So this is kind of nice. It looks simpler, right? How do I stop it? Well, let's insert another rung. And we'll add a reset command. And what should the reset command do? Well, it should reset Y12. What's the condition for it? Well, we got to be careful here, because if I do this and I reference the start button, or I'm sorry, the stop button, it'll constantly reset the light. Here's the thing. The stop button's normally closed. That means this instruction would normally pass power, which means that reset is going to be triggered every time the PLC goes through a scan, which is going to happen thousands of times a second. So I don't actually want that. So what I want to do is use an inverting instruction instead, and understand I'm not using this so-called normally closed just because the stop button is normally closed. No, I'm using this inverting instruction. That's really what it is, because the stop button is giving me this constant true. Well, what I really care about is doing the reset, or turning off the light, when the stop button is pressed. Well, when the stop button is pressed, it gives me a false. So false inverted here is true, which would cause the reset to happen. And so now I'm able to use the start and the stop button to turn on and off a light, just as I had before. So these two rungs are exactly equivalent to what I had before in terms of their functionality. Now, it might be nice to make the stop button work as well. And how would we make the stop work? Well, one way to do it would be to say, just turn the stop light on whenever start light is not on. But there's another condition here, right? We could have both start and stop lights off if no button has ever been pressed. So let's add in a few more rungs. Or better yet, what would make the stop light go off? Well, if we press cycle start, that would make it go off. So why don't we just add a condition here, or I'm sorry, an output, based on the condition of the start button being pressed, that will turn off the stop lamp. Now the stop lamp, I think, comes after start, so it's probably on Y14. Yes. And so now what will happen, every time the start button is pressed, the start light will come on and the stop light will go off. And then similarly, on the stop button, whenever the stop button is pressed, which would be, the stop button would actually be given as a false signal, which would transform to true through our inverting instruction. In that case, I would want to turn on, I keep doing that, sorry. I would want to turn on the stop light, see. So maybe it makes more sense to you to switch these around, that way set and reset is in the same order, but I like it this way where I've got the start light and the stop light in the same order. Now why am I showing you this? Well, mainly because there's a fundamental difference between an output type instruction and a set reset pair. An output instruction can turn an output on or off, whereas a set can only turn an output on, a reset can only turn it off, and you often see these in pairs. And it's not really that these two here are a pair, it's actually this one and this one that's a pair, because this is the instruction that can turn the start light off. The instruction on rung 1 is the one that can turn the start light on, you see. So if you don't have one or the other, you won't be able to turn the start light, or whatever output it is, to the opposite state. Now, of course, it's bad practice, but you could use an output instruction to try to do it, but that's bad. You don't normally use an output instruction referencing the same address as a set reset. Sometimes you might, but most times you wouldn't. It makes coding more complicated, it makes it harder to read, and so I would say it's not a preferred way of going about things. But we really haven't done anything yet, right? I mean, if I were to download this and run it, all that would happen is some lights would come on. It's a good idea as you're programming. I'm going to try to show you some good, forgot my end statement. I'm going to try to show you some good practices. And these are not perfect. There's other ways to program I'll teach you later. But I'll try to show you some good practices as you go along that will probably save you a lot of heartache, a lot of effort, and a lot of frustration. So I can turn the thing on. I'm actually not connected to the PLC yet, so let me go into the configuration or into the driver and actually connect. So now the factory I/O simulator is talking to the PLC. So if we go to camera navigation, you'll notice that the default is for things to be off when the PLC starts up. So even though I haven't pressed the stop button, Y12 is by default. Well, no, wait a second. That doesn't make sense. I know what happened. It must not have read the stop button initially, and so it would have assumed that stop was false. The inverse of false is true, and gone ahead and set the stop light on. That's okay. It doesn't matter. So if I press start light comes on, and you can hear. Let me turn it down a little bit because this is annoying. You can hear that a conveyor is on, right? That conveyor is actually the exit conveyor. If I go over here and look at it, hopefully you can see that the rollers are turning there. Okay. So we'll zoom back out here. And okay, that's nice. That's good. Something I wanted. But obviously I'm not really very far along. That was a little bit of success. But here's a good practice for you. File, save project. And after I get the next bit of accomplishment, I'm going to save project as and make a new version number of it. This is just the beta, if you will. This is just the beginning. Okay, so I'll go ahead and start modifying. Now let's think of what I want to have happen, because I can actually, before I make actual outputs come on, I could actually program that, maybe it'd be easier. Let's do something easier. I was going to say I could go ahead and program the logic for selecting back and forth between the two. Let's do something easier. What I'd like to do is get these pallets queued up. So let's start off with conveyor 1 because it'll be easiest. Basically, I'm not going to use, let's see, do I want to use set and reset? No, I think I'll use outputs. So I'm going to use outputs here. And what I'm going to do is drive conveyor 1. So let me select conveyor 1's address. I just want to drive conveyor 1. Oh, it's just Y1. Okay. I want to drive it until this sensor at entry 1 is true, because right now it's false. There's nothing sensed. And so once a pallet gets there, then that way it'll just shut off automatically. So let's see, at entry 1, there we go. And let's download this. Let's see, I'll put my end statement. Unfortunately, it won't let you drag an end statement down very far. It'll let you put it there, but then once you download it, it'll move it up. Well, it usually moves it up, I thought. Maybe not. Yeah, it doesn't matter. So go to run mode. And so now, let's see, you know what? I've got my logic backwards because, because at entry 1 is true when something's there. So I've got it backwards. I should have used an inverting switch. So there we go, C1. So let's download that. So when it doesn't see something, then move the conveyor forward. That makes more sense. Let's download this and make sure it works. There we go. So now that pallet nicely comes along. As soon as the entry 1 beam is broken, or in other words, it becomes true. Then the inverse of true is false, and it turns off the conveyor. So that's good. I could do the same thing for conveyor 2, but yeah, maybe I'll go ahead and start it. But I really want conveyor 2 to run as long as there's not something here, but I want it to keep running actually, because if there's not something at transfer 2, then I need to get something there. So let me make the condition just if there's not something at transfer 2. Okay, so we'll put in another output for conveyor 2. And we'll make the condition be that there's nothing at transfer 2. Now, of course, the load conveyor would have to run in order to actually get something there. So if I actually download this and run it, it won't work quite the way I want it to. So let's say OK, download it. So now something comes along, but unless I turn on the load in the transfer conveyor, you see how it just kind of gets stuck and waits for a pallet to push it. I don't want pallets butted up to one another because I really want to see the falling edge. I want to see the back side of the pallet. I want to see the sensor go from, you know, low to high or high to low, however you want to look at that. I guess in this case it would be from high to low. So this won't quite work, right? But I'm going to do a file, save project as, and here's a habit you should get into. Merge Conveyor version 1, v1. Okay, so I know that this is a little more progress than the last one, but if I decide that what I've just done here, for example with conveyor 2, is horrible, I can just go back one step, right? Or if there's something I delete out of this that later on I decide I want, I can go back to that version and pick it out without having to think through the logic again, which is actually a very wise thing to do. A lot of time in programming, you really don't know how you're going to solve a problem exactly. You just have to write some code that's close and then modify it later. For example, I know that I've got to make this conveyor 2 and transfer conveyor 2 work together somehow. They've got to both bring the pallet into the transfer 2 station. I'm not sure I'm going to do that yet. One of the unique things about the load or the transfer conveyors is that I've got to turn them on and off, right? I don't want them to just run continuously, because I mean, you could probably program it and make it work, but I would rather not. So I'm going to make them turn on and off, and so since I'm going to have to turn them on and off, and the conditions for turning them on is often different than the conditions for turning them off, it's much easier to use set and reset. Now you can use an output instruction, and you can make different conditions for it turning on versus it turning off, or different condition sets, but it's conceptually, I think, easiest to use set and reset. So I'm going to go ahead and tackle, let's just reset this simulator, because I don't really want to see any pallets there right now, and think about what I want to do, because there's really a whole process of moving conveyors through this system. For example, let's just say that I want a conveyor, I want conveyor 2 to move the pallet, let's see, from the load position. Let's just say somehow we get it into the transfer conveyor. I want it to move it from there. I want to move it over and bring it out of the system. So I want to program that whole sequence. How do you program a sequence like that? Well, let's just assume that it is conveyor 2's turn, if you will. Well, we don't really have to assume that. We can know it because we've got a bit that sets that, right? So I would have to know that it's time to send this on, right? So what does it mean for it to be that conveyor's turn? Well, I set a bit. I defined a bit called toSelected. So in other words, conveyor 2 would have to be selected to be the next one to go before I could actually bring it in and make it go, right? You know, maybe that's not such a good idea because part of the sequence is going to be getting the pallet from the conveyor onto the transfer conveyor. So how about if instead of doing that, how about if I hold off on deciding? Really, what I want to do is start the sequence by getting something in place, kind of pause the sequence, and then when it's actually transfer or conveyor 2's turn, then move it over and let it continue on. So I think what I'll do is I'll actually make this part of the sequence so that I can solve the problem of getting the pallet from conveyor 2 onto transfer conveyor 2. So in order to realize that I need to move it forward and therefore turn on these rollers, I think what I'll do is say, you know, if there is a pallet here, but there's not a pallet at the transfer conveyor, then get one there. Turn on the loading rollers and make it happen. So how do I say that? Well, all right, so if at entry 2 is true, so if at entry 2 is true, if there's something here, but there's not something at load 2, or not load 2, but at transfer 2, that's the name of the sensor, is at transfer 2, then what we need to do is we need to turn on transfer conveyor 2's rollers and get something in there. So remember I said that the transfer rollers will be turned off and on. Now if all I do is turn on the rollers, I've missed an opportunity because something important happened. A set of conditions was recognized that needs to be remembered. I recognized that I'm at the beginning of the sequence because I've got something at the end of conveyor 2 waiting to come onto the transfer conveyor, but there's nothing in the transfer conveyor. That's something worth remembering. So actually, rather than turning on the rollers, let me set a memory bit. I will set bit C1000, just because I know it's not being used for anything else. There's 2,000 coils or memory bits in this PLC that are available for our use. So I'll just go ahead and say, you know, turn on a bit, C1000. And oh, by the way, while you're at it, actually do something in the real world. Don't just remember that an event happened, respond to that event. So in other words, turn on the load 1 transfer roller set. Okay? Now, this is important. This C1000 is important because it lets me remember that a very important event occurred, just like this start light lets me remember that the start button was pressed. Okay? So I'm going to remember that there was a time when there was a pallet available at the end of conveyor 2 and nothing in the transfer conveyor, and so therefore I turned on the transfer conveyor. Okay? The next step in the sequence that's going to occur is, of course, the at transfer 2 signal will come on, right? That sensor will be true. So let me put that condition next, C4. But I really don't, that sensor being on by itself is not the only thing that's important. I need to remember that this has happened after I saw that there wasn't one there. So a bit that I'm going to add here as a condition for the next memory bit, the next event memory, is that actually, let me copy this, that'll be the quick way, copy it and paste it, is that actually there's something special about the at transfer 2 went true, that there's a conveyor there now. It's that it happened after the event of there being nothing there. Now there are many different ways to write sequences, and this is just, you'll just see one way. You'll just see the way my brain thinks about it. I could probably do it differently than this, okay? But I think I can make this work. Now sometimes you have to back up and try other things, but I think this will work. So an event happened, there was no pallet, and now there is a pallet. What does that mean? Well, that really means we're queued up and ready to go, doesn't it? That means that an event has occurred. So I will record that event with another bit. The next one in sequence makes the most sense, C1001. Now, when that happens, I need to turn off the load 1, don't I? So what I need to do is say, okay, I'm going to set a bit to remember we've arrived at an important point. but I'm going to turn off Y2, which is loading the, because I don't need the transfer conveyor to run anymore, right? Now, in thinking about this, if conveyor 2 is only driven by there not being something at transfer to, when I've got a pallet sitting here and it's just broken the beam and I turn on the transfer conveyor, actually nothing's going to happen. So I need conveyor 2 to work in tandem with me here. So let me put an OR around it, around the at transfer 2, and say, you know, actually I need conveyor 2 to run anytime that transfer conveyor 2 is running. So the reason for that is, of course, the pallet will primarily be on conveyor 2 initially, and so if transfer conveyor 2 comes on with the, not the orange strips, but that little section there, it's not going to be able to grab the pallet unless conveyor 2 hands it to it. So I'm going to make an OR like I just did and say, if transfer 2 is running, which is Y2, if load is running to load transfer conveyor 2, then I need for conveyor 2 to run as well. Okay? And I've been grabbing the wrong address all along. Hopefully you weren't too confused. I've been grabbing load 1, which is the transfer conveyor after conveyor 1. So all these Y2s need to be changed. What is the correct address? It should be load 2, not load 1. So I'm sorry if you've been scratching your head at this video so far. So Y7 is the one I want. It's easy to introduce bugs. It's harder to find them. Glad I found that one early on. So this one needs to be Y7 as well. Now this is not all of the sequence. This is sort of a pausing point in the sequence, because by the time we get to here, and you know, maybe it'd be a good idea for me to add a run comment. You should always comment your code, and so far I haven't done any commenting except for the, you know, address commenting for the main part. So what I'm going to say here is that we've got a loaded, ready pallet from conveyor 2. Now obviously when conveyor 1 stops, there's something at the entry, and so we've got a loaded, ready, you know, pallet at conveyor 1, but 2 is a little different, right? It'd be nice to get it to go forward and be on the transfer conveyor. So this is an important thing that has happened, right? So what do I want to do next? What's the next step in the sequence? Well, let's just assume that it is 2's turn. As I said before, we don't really have to assume that. We can have a bit that tells us, but this is a next step in a sequence, so we want to make sure that the previous step has occurred, that step 8 has actually occurred. And then what we will do is make sure that it's number 2's turn, right? That conveyor 2's selected. So let's go grab that bit. And understand I haven't made this bit work and do anything yet. It's just a bit in memory. Somehow, somewhere, I got to turn it on or toggle it back and forth so that conveyor 1 and conveyor 2 can run. And so here we go. Let's see. We're at this step in the sequence. The last step has occurred. It's selected, so it's time to actually continue the sequence and move the pallet over, transfer it over in the conveyor. So I want to remember that this has happened. So C1002, and you can get away with using many fewer bits than what I'm using here. I'm just doing this in a very simple way. It makes it very readable, makes it easy to understand what's happening, especially if I, you know, segment this all out into a subroutine that's constantly called. That makes it easy to understand that it's a sequence for that section. But I'm not going to do that for demonstration here, because I'd have to be going back and forth between screens, and I don't want to do that. But basically, I've remembered that I'm at the point where, okay, it's time to transfer over, so why don't we turn on the transfer rollers? So let's set not just a memory bit, but let's set transfer left 1. That'll turn on the orange transfer strips. It'll lift them up and turn it on. And by the way, you can play with the simulator and see what it does. If you go view, dock, I mean, you can dock all tags, but then they kind of get in the way, but I'll go ahead and do it so you can see them. So you can actually force things on and off. And if I can move this out of the way, I would. Let me undock them all. Let's clear docked tags, and then we'll move over just a little bit so you can see how this is supposed to work. Let's see, I think if I maybe move forward a little bit through that grate and then turn to look the other way. There we are, not quite so much. You can understand what happens. So if I guess I got to move over a little bit more and maybe zoom out just so that I'm not behind the fence. Behind the fence. There we go. And let me look at it. Maybe not quite so much. And then if I dock all the tags, I guess what I could do is get rid of a bunch of these. I don't want to see any of the sensors, so I'll just close all of those. I don't care about the counters. Let me get rid of all sensors, and then you can see all the outputs I have available. I don't know why it doesn't want to close that one. There we go. There we are. There we are. So you can see that I can just force outputs on. Right now the only thing that's forced are the two emitters, emitting boxes, and the remover back behind me, basically behind where I'm standing and looking right now. So I can force things on. I can just make things happen. For example, I could turn on conveyor 1. I could force it on. Now notice it's skidding. That's because the transfer conveyor is on. Now it's being pushed by the one behind it. So if I just turn on load 1, now things go through a little more smoothly. Of course, my exit conveyor is not on, so I'll turn it on as well. There we go. Now things are rolling smoothly. So as soon as emitter 1 gives me another pallet, you see that I can just let it come on through. You can hopefully see the transfer conveyor rollers turning in the video. So what I'm going to do first is just turn off my force of conveyor 1. It's still forced, and what that means is the PLC is not allowed to override it. If I release it, remember the PLC is trying to queue these up, so the PLC just turned on conveyor 1 to move it so that there's something at the entry. Rather than forcing that one, let me turn off the, I'm going to release the load 1 and the exit conveyor. In fact, you know what, I'll just, I'm going to leave the exit conveyor on. I could just press cycle start, but I don't want to move the view. So let me go through the whole procedure of moving a pallet over, not by grabbing it with this little hand tool I've got, but with the machinery to see how it works. So I'm going to turn on transfer left. Now, so this is the transfer conveyor 1, and it's on, and if there was something sitting on top of it, it would be pushing it to the left. I'm going to turn on transfer left 2, and that'll raise up the one that's actually holding the pallet, and you see that the pallet comes over. Now, of course, this other pallet was in the way, and so it hung up, but that's okay. I don't care about that right now. Now, in order to move this forward, you'd think, well, just turn on load 1, but that does not work because the pallet's not touching the rollers on the transfer conveyor. I've got to drop it back down, so I've got to turn off the transfer lefts. I don't have to turn both of them off. I did. I really just had to turn off the transfer left on transfer conveyor 1. But now I can turn on load 1, and it moves forward, see? So I've managed to move a pallet from conveyor 2 over to conveyor 1. Now how do I do that programmatically? Okay, well, the sequence is pretty straightforward. It's a matter of figuring out what conditions drive the next step in the sequence. And what I've decided here is, okay, 2 is selected, we've got a pallet queued up and ready to go, and if I were to move it over, I'll try to, I guess it doesn't want to move very much. I'll unpause the simulation, and yeah, that's pretty close, not quite. That's maybe a little better. Yeah, close enough. There we go. So I've got this pallet queued up and ready to go. That's what this says is, hey, if we're at this step, C1001, that means there's a pallet queued, right? And since number 2 is selected, conveyor 2, it's its time. It's its turn to go. So what I'm going to do is turn on transfer left, but I'm also going to turn on transfer left for the conveyor, the transfer conveyor that it's actually sitting on. Now, I don't think I got what I wanted. Let me draw a line down. There we go. And then turn on set for transfer left 2. All right, let's see. Transfer left 2. There we go. And so now I've remembered that I've gotten to this point. I've turned on the 2 transfer lefts, and what is it that gets me to the next step? Well, the next thing that's going to happen as this pallet moves, here's what you got to do. Between the steps, you got to think about what these outputs are going to affect in the real world, and what will be the next sensor that comes on. The next sensor that comes on will be the fact that there's a pallet at transfer 1. So the next condition is, okay, if we've accomplished the step of C1002, which was the last one, and now we sense that there is something at, transfer conveyor 1, okay, then that means that it's time to go to the next step. In other words, we need to lower those transfer portions and turn on load 1 again. Well, I guess we didn't have it on before, but turn on load 1 to actually send the pallet out of the system. So let's do that next. Alright, so let's see. We want to set another bit. We're using bits like they're free. It may as well be. C1001, we've got plenty of them. And so now I want to actually do several things. I want to turn off the 2 transfers and turn on the load. So if I say set and put it down here at the end, I want it to set load 1. So I want to turn on the rollers of transfer conveyor 1 like I had to do in the simulation. And it looks like I got that in the wrong place. Let me let's see. Let me put a couple of resets in because I need to turn off a couple of things. I need to turn off the transfer left 1 and transfer left 2. So those 2 orange things will go back down and stop trying to shift the pallet to the left. And I don't want set, I want reset. There we go. I need to also affect left 2 for transfer conveyor 2. There we go. And then what I will do is cut this instruction because that's not where I intended it, and then paste it here. So we'll turn off those 2 orange things, let them go down, and turn on the rollers to make this pallet that actually came from conveyor 2 go forward toward the exit. Now, I have to decide when I'm done with this, right? I got to decide when I have finished the whole process and this whole sequence is done and needs to be started over, okay? How do I know that I've successfully transferred a pallet from conveyor 2 all the way through to the exit? Well, here's the key. If a pallet goes through this exit sensor and we see that sensor go from on to off, what that means is that a pallet has just passed by it. Now, I don't really care if that pallet is from, set 1 or set 2. I want it to reset this sequence. Now, I've got to be careful with that because let me program it and then I'll show you what I mean. So I know that I was at C1003, so we had successfully moved one over and we're expecting it to come off. So the next step I expect to see, the next thing I really want to observe, is to see a falling edge on the exit sensor. So at exit, I want to see that sensor go from high to low. Okay, and if that's true, then we're done, right? We're done with moving that pallet over and sending it out. And so I actually need to reset some things, but you have to be careful what all you reset. Number one, I could certainly reset. Well, let me talk to you about this part. Remember, I said I wanted to break down the sequence into 2 parts. It's really important that I remember that was a goal, right? Oh, and I've got this end here. I better move it to the afterwards anyway, but I'll take care of that later. So the part that I want to reset, if a pallet has come out, it's possible another pallet has come in from conveyor 2 and has actually began this portion of the sequence, right? So what I would like to do is I would like to actually go ahead and at the end here where the pallet has left the system, I want to reset just this portion of the sequence, just the portion from where I knew I had till right after I knew that I had a pallet loaded and ready for action, right? So I want to reset bit 1002 and 1003 so that I know that portion of the sequence can run again. Really, it's a separate sequence, okay? So but I think about it all as one sequence just because that's the way I started it. But really it's two separate sequences. So what I'm going to do here is reset 2 bits. I'm going to reset C1002, and I will also reset C1003. Okay. So that means that this portion of the sequence could be run again if necessary. If 2 was selected and there's a palette ready to go, well, then we could run this again. Okay. But of course, well, is there anything else I need to do? Really, I think I just need to... Oh, I should turn off what I turned on. I turned on load 1 in the last step, so yeah, I should reset that. So let's turn off load 1, and that was at address Y2. So if getting to the end of a portion of the sequence should reset that sequence, well, where's the end of this pre-stage? In fact, I think I'm going to add a run comment here and say this is a pre-stage transfer conveyor VEYOR2 sequence. So what I'm doing is what I would call sequence programming, and then really this one is process staged palette, STAGED, palette from conveyor 2. In other words, take it over, get it out of the system, put it on the exit conveyor. Or you could say merge. Maybe that's a better term. I like that better. So go ahead and merge the staged palette. Now, like I was saying, if there's something that resets the sequence here, there should be something that resets the first portion, this pre-stage portion. What is it? Well, it's getting to this stage, isn't it? If we're at the point where we're going to go ahead and move that palette over, well, then that means that now there's the possibility for another palette to be staged. In other words, it's possible for the sequence represented by these 2 rungs to happen again. Now, do I really want it, do I really want to go ahead and turn on everything here? I don't think I do. I don't think I want to turn it on here, because if transfer left is on, that means those things are raised and in the way. So I don't want to try to run that pre-sequence again. I would rather wait until the next step. Once I know that the palette has shifted over, it's out of the way, I'm shutting off those orange rollers, I'm turning them, I'm putting them down. I think I'll actually want to reset the sequence here at this stage. Now let's see, does that mean I need to reset this? No, this is the beginning of this sequence. So C1002 should be, and 1003 should be reset here, which is what I've got. But I want to reset the upper portion of the sequence here, 1000 and 1001. Let's see, where did I say? Here, I think. But I don't want to reset 1002 there. So I need a little bit more output here. So I'm going to reset, let's see, there's 2 of the bits. So let's see, let's reset C1000, and let's reset C1001. Okay, so I like this so far. Let's see. So I'll reset, let's see, 2 and 3. Yeah, down here. Okay. Just trying to keep all this in mind. It's kind of hard to program when it gets long like this. I wish they had it where you could condense these down, but it's okay. Now there may be more conditions I need to add in here that I'm not thinking about. I may run this and find that this doesn't work. And so I call this either truth table programming or more by the seat of your pants programming, if you will. This is not a very good way to program, and I'll teach you some better ways later. But you have to become familiar with what all this works and how if you don't have a plan and a structure, things can become very difficult very quickly. I want you to see that. Of course, I'm leading you through the activity, but there are better ways to approach this. But the idea here, basically what I'm doing, if you're used to a regular programming language, a structured text type, where you're, C or MATLAB or Java or I don't know, Python, anything like that, those programs, when you run your program, you compile it and run it, it goes line by line. And technically that's the way all computers, even PLCs, work. However, it's better to think about a PLC program as scanning. So it's not like it goes to one line and waits for something to happen and then goes to the next. Rather, the PLC evaluates the logic and sets the outputs very, very quickly, line by line by line. It just flies through it very quickly. And there's a problem with that because the order, the flow that is inherent in most programming languages is really not there in PLC programming. And so what I'm doing by adding all these bits is I'm forcing an order to occur, right? What I'm doing is I'm saying, okay, an event happens, I want to remember that because I know I'm going to fly down quickly to rung 8, the PLC is going to evaluate it, it's going to evaluate 9, it's going to evaluate 10, and so on and so forth. But I don't want 8 to really happen. I don't want these things to happen until what happened on the previous rung, or until the conditions on the previous rung actually happened, actually occur. So what we're really doing is forcing a flow to it, a sequence to the events that occur that match the sequence that we want to occur. We're creating the sequence. And so far I think I'm fairly happy with this sequence. I think what I might do is just turn on a bit. Let's say it's always 2's turn. Okay. So let's just turn on a bit and see if this sequence works. And maybe I should debug this. In fact, maybe I should save this as a new version. So save project as, we'll call this V2. I've added a lot to it. And so instead of having the end here, I'm just going to force a bit on. That bit will be my selection bit so that the second conveyor is always selected. Let's see, where is that? Oh, it's over in the bits area. So 2 selected. So that one will just always be on. There's no conditions, so it's turned on repeatedly, but that means it just stays on. And I'll put an end here. And we'll see if this will successfully, let's see, it should bring pallets up to conveyor 2. Should also bring them up to conveyor 1, but nothing will happen with those. And then if there's nothing there, it'll turn on the conveyor to get something there. If load 2 is running, it'll run conveyor 2. So that's good. So let's actually download this and run it and just see what happens. I want to clear my forces on let's see, load 1 and the exit conveyor. Let's see, transfer left will need to be released as well. There we go. So okay, go to stop mode, download the program to the PLC. I don't want it to go to run mode yet. I want to clear all my docked tags, and I want to reset this simulation and then let it play. So now we'll go to run mode. And let's see, this one should stop. So yeah, conveyor 1 stopped. Conveyor 2 comes in, it's transferring over. This is nice, the sequence seems to be working. And of course I don't have my exit conveyor on, so things messed up. That's okay. Why is my exit conveyor not on? Oh, because I didn't press the start button. It would help to press the start button. So I'll tell you what, let's go over and turn around and look at the start button and press it. Yeah, we can press it from the side here. That way I can see what's going on. And then what I'll do is just reset. Now, one of the problems with resetting the simulator is that, remember, the sequence was running and it said, hey, there's a pallet here ready to go. It remembers there's a part there. This is called a ghost part. Well, I guess it didn't ghost like I thought it did. But a lot of times that'll happen. You'll be stuck in a sequence. You'll yank something off the line, and the PLC is remembering that there's something there. It doesn't know you removed anything off the line. And so I'll demonstrate that for you here in just a second. And it gets stuck in part of the sequence. So here comes a part. I'm going to make a ghost part. We'll yank this. Well, maybe not that one. Can't seem to grab a hold of it. It's too quick for me. I'm going to wait down here and see if I can grab it. If I can't, we can run the simulation at a slower speed. There we go. Now it's nice and slow. But it won't let me grab a hold of it for some reason. Anyway, you can imagine how a ghost part would mess up the sequence, because it might... Here, I know how I can do it. I'll pause this, and I'll just remove the palette, if it'll let me. Okay, we'll just stop it. Well, it's not letting me remove the palette. So, well, I guess I did, right? Because I stopped the simulator from running, which by default removed the pallets. So now the PLC should be stuck at that step in the sequence, thinking that, hey, I'm transferring something over. It should be moving over, right? And so it's stuck. So load 2 is on. That's why it tried to come on in. And we were at a point. Actually, this tells me I think I've got a bug, because it should not be trying to transfer a conveyor from, or a pallet from conveyor 2 onto the load, the transfer conveyor, until the levels have gone down, right? Until the transfer pieces have gone down. So I'm going to have to think about that. But why don't we make the sequence for the other side as well? Because I need to merge these two eventually. And I need to figure out the logic for making that bit toggle back and forth. So the sequence for the other side should be pretty easy. Why don't we just go ahead and do that? So if, let's see, if it's, well, let's see, I grabbed the wrong instruction. If it's not conveyor 2's turn, so I should have said it this way. If 2 is not selected, that means 1 is selected. Then what I need to do is let the conveyor turn on and come on in. So what I need to do is somehow turn on conveyor 1, and let's see, what options do I have for conveyor 1? I know I'm going to OR around the command I have right now. There's no OR there. There will be something at the entry, so this condition right here won't let the pallet through. So I will need an OR of some type, just like I have here. But I don't know what that looks like yet. I have to have some way of making conveyor 1 come on in this sequence down here where I'm moving a pallet from conveyor 1 on to transfer conveyor 1. So let's see, if 2 is not selected, then it's 1's turn to go, and what we want to do is turn on load 1. So we want to turn on the transfer conveyor to bring in the pallet onto transfer conveyor 1. And you know what, I should have set a bit first. Let me sketch this, bring a set, and I'll actually put Y2 down here, because I always prefer to have my bits first for whatever reason. And so I'll just grab another bit. I don't know what's available. Let's say C1004, I think, is one that's unused. Looks like I stopped at 3 on the last sequence. So C1004, that's just the memory that, hey, 2 is not selected, it's 1's turn to go. Oh, and I wouldn't want it to go unless there was something there, so I'd have to know that there was something at that entry. So at entry 1 would be right there. So let's see, at entry 1 is true, so 1 is selected and 2 is not selected. There's something there, so we need to pull it forward. The next thing, so remember, this is a play back and forth between what the PLC commands to happen and then the PLC waiting a long time for the mechanical system to respond. So the mechanical system, what I've done is I've made it turn on this load 1 on the transfer conveyor, but the PLC is going to be waiting to it, what seems like an eternity, for the pallet to come forward. How does it know when the pallet comes forward? Well, it knows that the pallet comes forward when at transfer 1 goes true, right? So if what's happened is we accomplish the last step, in other words, C1004 is true, and now transfer 1 is true, in other words, there's something there. Let's see, at transfer 1, then I'm going to go ahead and set another bit. Now you'll notice the way I like to program, I like to, instead of using my pointer, a lot of times I like to leave the draw tool on, because you can pull instructions over and you can also draw lines at the same time. There's a few times when I have to go back to the pointer, but I'm in the habit of leaving that on most of the time. Anyway, so what did I want here? Well, I wanted another bit, right? Something important has happened. C1005 should turn on. And do I really need this step? Well, maybe not. Maybe I could just wait until, you know, the exit beam goes from true to false, right? But I'm going to add this in because I want to know what's happening in the sequence. Okay, so then what? What's next? Well, let's see. So at transfer 1 will go on. The at entry is going to go off, but I think I'll just leave that off for now because I want conveyor 1 to come on and bring the next pallet up. So I don't really care anymore about at entry 1. If I know I've got a pallet at transfer 1, and I think the pallet's long enough it would still be holding both on, that's good enough for me, because the next thing in the sequence is for the exit sensor to go from, you know, true to false. So I think I'm just going to add that in as my next step in the sequence. And a lot of times it's a good idea, especially if you have a longer sequence, to lay out, you know, what input conditions you expect to see. That's what's going in over here. And what outputs you then need to set to make the mechanical system move to the next step and the next set of conditions. The next set of input conditions. You can actually set up a sequence in Excel nicely and then create all your rungs of ladder logic from it. And it's a good way to do it. Maybe I should have done that this time to demonstrate it. But I'm really trying to demonstrate how difficult it is to program just without a plan. It's always important to have a plan. But on the other hand, I'm also trying to teach you how to think about these things and figure out what the logic needs to be. So let's see, the last step has been accomplished. We know we got something at transfer 1, and so what I want to do is see that the exit sensor goes from true to false. In other words, the pallet is completely on the exit conveyor. It's dropped the exit sensor, and so that means that, sure enough, you know, we've successfully moved a pallet through from conveyor 1. Now you might think that setting and clearing that bit that hands off the sequencing, or the hands off the next to the two conveyors should be set or cleared during the sequences, and that's possibly true. That may be a good way to do it. That's not the way I'm going to do it. I usually do overcomplicate things, so it probably is better to set and clear the bit within the sequences, but I won't do it that way. Maybe I'll do a little bit of Excel to show you how to figure out what should turn that bit on and off. So let's see. So once it has cleared the exit, oh well, we need to reset all of our bits, and we should turn off load 1. So I guess the thing to do is just do a bunch of resets. I'll reset everything in the sequence. It would be a good idea to make run comments. This is the process palette from conveyor 1 sequence. And so I've got that set up, the process palette from conveyor 1 sequence, and well, all I really need to do is clear 2 bits and clear that. So that'll be 3 different things to clear. So let me add space for 3 resets. One of the resets will be well, C1004. Another one of the resets will be C1005. And then finally the last reset will be Y2 to turn off the transfer conveyor. So Y2, the transfer conveyor, and transfer conveyor 1. So now what I'd like to do is build the logic for setting and clearing the bit, the selection bit. Let me show you how I'm going to do that. I've already made a spreadsheet, so I'm just going to open it up in the interests of time, since I know this video is going to be fairly long anyway. I'm going to open it up, and let's see, I called it Merge Conveyor. I actually set up several different schemes. I was trying to figure out how I wanted to do this. I finally ended up using simple finish flags, and what I mean by that is I finally decided, I think I got away from using servicing 1 and servicing 2. I realized that I actually didn't need that. All I needed to do was realize that there's only some things that matter. If there's something at entry 1, what that means is that I've got a pallet at the end of conveyor 1 that's ready to be processed. If I have something at transfer 2, that means I've got a pallet from conveyor 2 that's ready to be processed. And I realized that the next value of the selected bit should depend on the current value. In other words, the conveyor I'm going to process next depends on which ones I'm processing right now, right? And so I decided to simply use one bit rather than using those servicing bits. Sometimes it's good to have a bit that keeps track of, what you're doing right now versus what you're planning to do next or what you've done in the past. But I got away from that because this is a fairly simple problem and I didn't really want to overcomplicate it. So if I have 3 different inputs, what that means is I've just got 8 different conditions. So you can see all the different binary combinations that are possible. And all we really have to do is figure out what all these mean and what our resulting computation should be. In other words, given this information, whichever case we happen to be in, one of the 8, what would I do next? And so you can interpret this as something in the real world. Now I've defined the 2 selected bit. When it's off, that means conveyor 2 is not selected. When it's on, that means it is. And it's a little confusing because when 2 selected takes on a value of 1, what that really means is that it's not conveyor 1 that's selected, it's conveyor 2 that gets to go next, you see, or that is being processed. And so it's a little confusing, but I'll try to take you through it. If 1 is selected, that's what this 0 means. If it's 1's turn to go, and there's nothing at either place ready to go, why would I bother changing the bit? Why would I do anything? So I just put an X there to indicate I don't care. I'm not going to program this condition. If I see that condition, I really don't care what happens to the bit, because what really matters is whichever pallet is in position ready to go first from conveyor 1 or conveyor 2. That's the one I want to process. So I don't care about this condition. Similarly, if conveyor 1 is selected, that's what the 0 means, and there's something ready to be processed, and there's nothing ready to be processed at conveyor 2, well, this X means something a little different than the previous X means. What it means is that I don't want to change the bit. There's no point in programming this because we've already selected conveyor 1. So why would I change that? Why would I put a 0 here? Because it turns out I'll have to program all the 1s and all the 0s here. I don't want to change it, so I'm just going to put an X there, meaning I don't have to program this one. This one I don't care about. When this happens, I couldn't care less what the bit comes out as. When this happens, I have no desire to change the bit. I want to leave it as a 0, okay, because it's already a 0. There's something at conveyor 1 ready to be processed. I've already got conveyor 1 selected to be processed. Fine, it'll be processed. Okay, that's what my other code, my sequence code for the transfer and everything takes care of. And then if I see this, well, what's this condition? Well, conveyor 1 is selected. It's the one that we think we're going to process next. There is nothing to be processed at 1, but there is something to be processed from conveyor 2. Well, if there's nothing to be processed at 1, we should process whatever is in 2. So I'm going to change the status of the bit. I'm going to change it from saying, hey, let's process 1 next to, well, there's something at 2. Let's go ahead and process it. So I'll set the bit. This is something I need. I need to turn on the bit here. On the other hand, if 1 is selected, that's the one that's supposed to be processed next, but we have a choice. There are 2 that are ready to be processed. Well, now I've got to think of this 2 selected as what was selected last? What did I think I was going to do, or what was I doing? Because it's certainly possible that I could have been I could have had conveyor 1 selected, that's what this means, and I have processed it and it's done. Well, there's another one in place ready to go, but wait a second, I just processed something from 1. It's 2's turn because there's something there. This condition is the whole purpose of this bit. It's for taking care of the times when there's an option of processing the pallet from conveyor 1 or 2. So I'm going to choose to process the one from 2 because it's that one's turn. In the case where 2 is selected, so I say, well, I want to process whatever comes in from 2, but there's nothing at 1 or 2, why change it, right? I could change it back to 0 if I want and basically be here, but there's no point. So there's no point in changing the bit here, just as there's no point in changing the bit at this condition. So this is another, I don't care. I'm not going to bother programming it. If I have selected to process stuff from conveyor 2, that's what this says, but there's something at 1 ready to be processed and nothing at 2 to be processed, then I need to choose to process what's at conveyor 1. What could have happened is I could have been processing something from 2, maybe it's finally exited, and the next one I want to process is from conveyor 1 because there's something there to process, whereas there's nothing at 2. Now here I've got, let's see, I may have made a mistake here because actually 2 is selected, there's nothing at 1 to process, and yeah, I can simplify this, and there is something at transfer station 2, so there's something from conveyor 2 ready to process. I don't need to change it. I should have put a don't care there. I don't have to change it at all because the bit is already set, right? In other words, I'm already planning, or I've already processed something from 2, and I have nothing to process from 1, so we may as well process what came in from 2. I'll just leave it set. Now finally, here's another set of conditions that represent the whole purpose of the bit. When there's something to process both at conveyor 1 and conveyor 2, but I've just finished processing something from conveyor 2, then I need to process whatever's at conveyor 1. And so I need to change this to a 0. So I've got 2 zeros to process or to program and 2 ones to program. So this is how I will program or decide what the bits should be next. This is how I'll calculate the next value of that selection bit, if you will. Okay? So let's see. Basically, there are 2 sets of conditions that can turn the bit on, and there's 2 other sets of conditions that can turn it off. So I've got a set and a reset. Now let's see, the address of the bit is what? It's C12. There we go. And the conditions for setting, in other words, the times when I want to set it, are these conditions. So when I see 0, 0, 1 or 0, 1, 1, I want to set the bit. So let's program that out, and then I'll show you a way to simplify it. Let's see, that's 3 different things, so let me move over to the third area over. I'll have an OR that can accommodate 3 instructions, and it is as easy as dragging over something to invert these. Let me show you what I mean. So I'm going to take a inversion here and reference C12. So this represents this condition right here. This condition will reference at entry 1 being false. So we invert that to true, in our calculation at least. So that's at entry, what was it, at entry 1. And then the last condition is something at transfer 2. So do we have a pallet ready to process at transfer 2? At transfer 2, there we go. Now I could have used the sequence bit, right? I could have used that here basically to say, hey, there's something ready to process, but I would rather just use the sensor value itself. I try to avoid using these bits unless I have to. There's a way I'm going to teach you a program where you use these bits or something like them exclusively to drive outputs, but I'll show you that later. So this upper rung represents this set of conditions. And what it does is, if these set of conditions occur, it turns on C12, which is what I want, right? Because if 2 selected is false, then this will be true to let power pass. If at entry 1 is false, this one will allow that power to continue to pass. And if at transfer 2 is true, then power will go on and C12 will be set, which is exactly what I want. But there's another set of conditions, and that's what the OR branch is for. Notice that it uses the same addresses, so I'm going to cheat a little bit here. I'm going to copy these and paste them. And the only purpose of this is just to get the addresses first, because I don't want to go through the dialog box and select the particular addresses. But the conditions are different, right? I need a 0, 1, 1. So this one being 0 is fine. This one being 1 is fine. This one needs to be the other condition. Okay, so now this lower rung represents this set of conditions, 0, 1, 1, on the inputs, and of course it will calculate a 1 as the output just as well as the other one would. Now, one thing you should notice here is that these are kind of redundant, right? I mean, it doesn't matter if C1 is on or off. If 2 is not selected and there's something at transfer 2, well, I don't care if there's something to be processed at entry 1 or not. It's 2's turn, right? If there's nothing to be processed, let's process what's over at 2. But I've already processed apparently something at 1, so this doesn't matter. As a matter of fact, these two 1s collapse into a single. This is actually a Boolean simplification. It comes from the fact that these two are different, but the other two here are the same. And so I actually don't even need this OR branch. Basically, if I've either just processed something from 1, or it's what is selected to be processed, but there's nothing there to process, or there is something there to process, but there's something to transfer 2, then let's process the pallet from conveyor 2. Okay, that's what this says. A little more English. Is there a simplification that will occur with turning the bit off? Actually, there is. Do you notice that these two are the same, and these two are the same, but I don't care if at transfer 2 is true or false. It's time to process what came from 1. It's actually the same kind of thing. So I'm going to reset C12 anytime I see that 2 is selected, so I'm thinking that I want to process whatever is over at transfer conveyor 2. So I want to say the other way. Okay, so 2 is selected to be processed, but if there is something at 1, let's see, at entry 1, I'm going to go back and get that address. Then I don't care if there was or was not something at 2. I want to process what's at entry 1 because apparently 2 has just gone. Now, there's one problem here. These rungs are going to be evaluated over and over and over, and it's just going to set and reset bit C12 repeatedly, especially as things enter and leave. And so this is going to cause chaos. I have to somehow differentiate what I remember that I've either been processing or that I think I want to process next from actually choosing to process something different. So when should that happen? When should I update the value of this? When should I choose the next one? Right, it's kind of like when do you choose the next king? Well, when the old king dies. When does the old king die? Well, when is it time to select what to do next? Well, once a pallet has gone through here, that's when it's time to select what we're going to process next. So there's one more condition I'm going to add onto both of these rungs because I don't want these bits turning on and off willy-nilly as I go through the sequence and move pallets through, to get them into position to be moved onto the exit conveyor. What I want to do is only calculate a new or a next, make a decision about which to process next when this exiting sensor falls. Okay, so what I'm going to do is put one more condition, and I think what I'll do is move these over to really emphasize the fact that nothing's going to happen until a pallet or no decision will be made on the next pallet to process until the current pallet that's being processed is done. And we know that happens on the falling edge of at exit. So when the sensor at the exit goes from true to false, that's when it's time to select the next pallet to process. Okay? I made a lot of changes. I'm going to do a file save project as. Notice I'm not just hitting the save button because I want a new version, version 3. Okay? Now this should be interesting. I should have the functionality for selecting between the two bits. Those bits then can help determine whether or not the sequences should run. If 2 is not selected, then this sequence is dependent on 2 not being selected. In other words, 1 being selected and running that sequence. Similarly, processing a pallet from conveyor 2 is dependent on that same bit. And I think I've managed to clear all my sequence bits at the right time. I think we're good to go. Let's download this and see what happens. It's always important when you're writing a program. Oh, end statement. I always forget that. This is the one programming or ladder logic programming language I know of that requires an end statement. I don't think many do. Maybe I just haven't seen very many PLC programming languages. Oh, another syntax error. Okay, so now what's it upset about? So now I'm glad this happened because I want you guys to see me make a mistake and see how I recover. Let's see, merge version 3, 1 error, 0 warnings. Warning, error, short circuit on rung 4. Okay, so probably something I forgot. Oh, I did forget something. Yeah, on rung 4, remember that. I was trying to figure out when to turn on conveyor 1, and I'm glad that this error happened because if it would allow me to run it, I couldn't actually load a conveyor into transfer conveyor 1 from conveyor 1. Because I've got to have something in this OR to turn on conveyor 1 during that portion of the sequence. So let's look and see. You might think, well, we should just make it depend on when load 1 is running. In other words, when the rollers are running on transfer conveyor 1, shouldn't we turn on conveyor 1 itself? Well, the problem with that is that, remember, we sometimes pull a pallet over from conveyor 2, bring it over, and move it onto the exit conveyor. I don't want to automatically just pull in a pallet from conveyor 1 directly behind a pallet from conveyor 2. So what I'm going to do is actually look at the sequence, and I'm going to break the rule I said a little earlier. I am going to reference some of the bits because I want to know where I'm at in the sequence, and I want to make conveyor 1 run when we're processing a pallet from conveyor 1. So in other words, when C1004 is on and load 1 is trying to get the pallet to come onto the transfer conveyor, I need for conveyor 1 to run. Now, once the pallet is at transfer 1, it should be far enough onto the transfer conveyor that I don't want the conveyor 1 to run anymore. So I'm going to turn it on when C1004 is on, but remember C1004 remains on through the sequence, and so I'll turn it off when C1005 comes on. So there's going to be an AND condition here. So it looks like I'm going to need to move this over. I'll have to draw it a little bit differently. Let's see, something like that, and then let's erase that line. And the conditions are that C1004 has to be on, but I want it to turn off when the sequencer goes to the next step, C1005. Okay, that way the load, or the conveyor 1 will be on only when load 1 is on and needs the conveyor to help it. Okay? Alright, so that error was actually helpful. Let me save this. That was just a bug, so I'm going to overwrite V3. That's something I should have remembered to do. So when I'm adding large functional sections like that bit function, that's when I usually add a new version number. Transfer is complete. Go to run mode, and I guess it would help to start the simulator. And I'm going to pause the simulator. That way I can get over to the start button before the pallets actually are ready to be processed. Unpause, and now I can hit start. And there we go. Alright, so that processed a pallet from 2, and it's processing another one from 2, and I don't want that. I wanted it to process the pallet from 1 next, and it did not do it. Okay, so now I've got a bug in the code. Let's see if I can figure out where that bug is. Since the code is shown in the PLC software, I can tell what's turning on and off. So let me go down to the sequence for well, better yet, let me go and look at the bits, because I don't think my bits are doing quite what I expected. So when there's a falling edge, which is right there, I know what's happening. No, I don't know what's happening. This comes on whenever that sensor, that exit sensor, goes true, but it doesn't actually trigger through the rung until the sensor drops, until the falling edge occurs. So there's nothing to transfer to, and it drops right there. When it drops, that should have set this bit. Now it reset it. So now we're choosing 1. Now how did it get set again? Well, I'm not sure what's wrong, because when the pallet drops the exit signal, let's say we process something from 2, we know that the bit was selected. That's why the sequence was able to run through and actually move the pallet over. So I'm glad I got the transfer working. That's good. That means it was selected. It does leave the system. It goes out the exit. That's why it drops. And there is something in entry 2, so that means that this instruction should certainly reset C12. Now, the PLC is scanning, so the next thing it's going to do is it's going to come through and very quickly end up at 15. And the only place that can turn the bit back on is rung 15. If you look through the program, there's no other place where C12 is referenced. We can verify that. Let's see. Yeah, so in looking through this, well, no, there is a place where C12 is referenced. I just saw it. I thought I saw it. There it is. I had forced it on before. There's my bug. Remember, I had forced it on to make the system go through and process. Now, so this is a classic problem. This is something that happens all the time. It is often a very bad idea to have an output set or reset 2 different places. Now, with set and reset, it's harder to avoid. A lot of times there's other logic where one portion of the program needs to turn a bit on, maybe some other portion of the code needs to be able to turn it on in other situations. But you see this problem more often with just output instructions themselves, where students will figure, well, here's the logic for turning it on and off, and write that in 1 rung, that's done. And later on, they need to turn that particular thing on or off, and they write another rung that overwrites what their previous rung had done. Basically, it's a new calculation. If I tell you, okay, x equals 3, and then tomorrow I'll tell you x equals 4, and I say, what does x equal? Well, I've overwritten the value of x, haven't I? So, yeah, I made a mistake. I forgot that I put this in here for troubleshooting, and I basically had 2 different rungs computing the same output when it shouldn't. So, now let's download this and run it. So I was racking my brain trying to figure out why my logic was wrong, and I had just left a command in that didn't belong there. Okay, so I think why don't we just reset this and then unpause it. And now if I pause it, I want to make sure I'm not in the middle of a sequence somewhere. C1001 is reset. Yeah, 1001, 1002, and I guess 1000 are, yeah, they're all reset. So we're at the beginning of the sequence. Notice the bits come on and they stay on throughout the sequence until they're reset at the very end. And then 1004 looks like it is set. And I'm not sure that I like that. Process pallet from conveyor 1 sequence. Why is that set? Well, we'll see what happens. It's running. What I'm going to do is go over to the control panel as I did before, so that when I unpause I can press the start button, and that way everything should be working. So there's nothing. Now I don't like this. Look at this. we're not processing the pallet from 2. Now remember, the bit is not computed until this drops, and so we've got a bug here. Let me pause it. So it's really not a surprise that the pallet from 2, even though it was ready, was not processed, because the default condition for C12, the memory bit, is to be off, meaning that the pallet from conveyor 1 should be processed, and we don't recompute the value of that bit until something lets that exit sensor drop. So maybe there's a way to improve the code, and if something appears here first, make it go over. But I'm not going to worry about that. I'm going to let that happen, because after this pallet goes through, so a pallet from conveyor 1 will always go through first. That's fine. After it goes through, what will happen is the bit will be computed, and then the pallet from 2 will go through. So that should be okay. What I don't like is how the pallet got here and just stopped, and I want to figure out why. The exit conveyor should have been running because I had pressed the start button. If we look at the top, the exit conveyor is running. That output's on. Conveyor 1 is running, but apparently what happened was the transfer conveyor 1 shut off. So I think that load 1 is off. Let me go look at the sequence for conveyor 1. Yeah, load 1 is off, and it should be on. Why is it off? Well, we somehow got to this point. Oh, because I've got a rising edge instead of a falling edge. Of course, I think I said falling edge, and I must have said rising edge. This is kind of like the scary movie, right, where the person's not watching what's going on, and you're screaming at the screen saying, "Hey, you said this, and you meant to do this, and you messed up." And probably most of you have been looking at this wondering why I said I wanted to see the falling edge, and I put in the rising edge. So sure enough, it saw the rising edge. The pallet hit that sensor and shut off the conveyor. So anyway, there we go. So now let's go to, first of all, let's just reset the simulator. So we'll go to run mode. And again, I'm going to go over here where I can press the start button because I need that exit conveyor to run. And really the start button should do more than it's doing. I'll add that functionality in a moment. So unpause, we'll go to run. And looks like the exit conveyor is moving. Pallet from 1 came through first anyway. It moves through. Will it move over? It should have moved that one over, and it didn't. Now it's going to transfer over to, let's see if it works any better. Here we go. It stopped 1, brought 2 over. This is looking pretty good. We'll let it run for a while and see if everything's okay. The reason 2 pallets went through from conveyor 1 is that the first pallet went through and allowed a computation of which pallet should be next. But even if there was a pallet at conveyor 2, there was also another one at conveyor 1 that was ready. And so how would that have worked? The bit would have been reset. Well, it seems like it should have gone over to 2, but well, it seems to be working now. Maybe the boss won't notice if it doesn't actually merge the very first set of pallets. Maybe we can get away with this. What I'm really saying here is that I'm being a lazy programmer. I'm letting the software dictate the way my program works, and that's not good practice. There's a lot of things I'm doing here that are not good practice. There are much better ways of doing this, and so I'm not going to bother fixing all of the problems. I'm going to let you struggle with this for a little while, struggle programming this way so that you appreciate, and I don't mean are grateful for, but I mean so that you really learn the importance of the programming methods I'll teach you later. So again, there's better ways of doing this where you use fewer bits. It's a little more bulletproof than a sequence, but sequences are often quick and dirty, and often they can work just fine because many times a PLC just does a really simple task that if you asked a human being to do, they wouldn't last on the job a day because it's just such a boring task, and they'd be probably looking at their phone and mess up the process. PLCs are very patient. They're willing to just sit there and take on the most menial of tasks. So I like this. It's working. Oh, we got a problem. What happened there? What happened, let me pause it. What happened was it tried to make both go. Now, how could it try to make both of them go? Well, let's look at the bits and see what it has selected. Remember, the bit has not been recomputed yet. What's selected right now? Well, it's reset, meaning that one should have the chance to go. So why did the pallet from conveyor 2 decide to slide over? Well, apparently we caught it just right. Apparently what happened was, notice that the code for the sequence comes first. And there's still some time for the, let's see, would that make sense? I don't know if that makes sense, because the mechanical system is going to happen very, well, it's a bit, so the bit could be set very, very quickly. So let's just theorize that, well, no, it would have grabbed all of the inputs at once. I was going to say, let's theorize that pallet 1 triggered the at entry 1 sensor when there'd already been the decision made and the sequence had started to moving pallet from 2 over. And so then the computation at the end here said, well, let's just let 1 go, because 2 has already gone. I don't think that holds water, though, because all of the inputs should have just been grabbed at once, and then all the computations performed, and then all of the output sets. That's a standard thing that PLCs have worked with for a very long time, and that's the reason that there are so-called immediate addressing. If I put just for demonstration purposes here, if I put this in and say, you know, I can't use a C address like C12 because there's no such thing as immediate addressing there, but there is immediate addressing for real inputs. So let me just, even though we're not using any, let me grab a real input address like X1. Immediate addressing means that I know that PLC, you've already gone and you've already read the status of all the inputs, and you're trying to calculate what the output should be based on that list of inputs you got, but I want you to update this one particular input when you go and you evaluate this rung. Notice there's an I there for immediate. And so what the PLC will do is once it gets to this rung, it will actually not really stop, but it'll go out and say, okay, well, you want me to look at this? Okay, I'll go grab that one input and see what it is right now, because maybe it's changed as I've gone through this long program. And if your scan time gets long, immediate addressing can alleviate some problems. But I don't think that's what happened. I think what happened is something like it, because if you think about these bits, I don't have the option to set them as immediate or not, because that's only for X bits. These are by default immediate. In other words, they are going to be read from memory at the time when they're processed or when they're needed. And so they are updated automatically, and you know, C1003, once it's on, immediately this rung will realize that it's on, and you know, the next conditions can happen if necessary. But anyway, the reason it doesn't, because the mechanical system takes a long time to respond to what this rung has done in order to get to this rung and actually satisfy the conditions for the next step in the sequence to occur. Anyway, so actually I think I do have an immediate addressing problem, because I'm using, instead of real inputs, I'm having to use memory addresses which are updated immediately. And so it is plausible that what has happened is, you know, there was the calculation to say, well, there's something here. Well, does that still make sense, though? I think it's still possible. So somehow I have to keep that from happening. It's really just a byproduct of the fact that I'm not using real inputs on the PLC. I'm using memory addresses just so I can communicate with this simulator. So what could solve the problem is if there's a way in my address pickers to say, you know, that these will not be reevaluated during the scan. But that won't. There's no way to do that, and it would be a little bit clunky anyway. So I'm not going to worry about that. Let's see, what could I do instead? Well, you know, in thinking about it, I realize there is a problem fundamentally here. In that my sequence for the pallets coming in from conveyor 2, where is that? Here we are. there's a problem here because really I've got two separate sequences. I've got the sequence on 6 and 7 and then the sequence on 8 and 9 and I think 10 or so, yeah, that follow on to that first sequence. So there is a problem here because it's entirely possible that I would preload a pallet. It's ready to go. It's here at, you know, the transfer conveyor, and then I start merging it over. Let's see, but let's say it gets stuck over here for some reason. It stops over here, and then I start to load another pallet. Well, if I start to merge the pallet here on 8, then get to this step where I've got something at transfer 1 but it can't go on. Notice that I have reset 1000 and 1001, so it's possible for another pallet to come on. That's all well and good, but the problem is if I get a pallet at the load or at the transfer sensor here and there's the one over here stuck for some reason, then this pallet's going to think it can move over because conveyor 2 is selected, right? So why can't it go ahead and move over? So what I want to do is I want to make sure that I don't actually get into this. Is that what I want to do? No. Yeah, I don't want to get into this unless 3 is set. In other words, I want to make sure that whatever was already being moved over has been moved over, because I can safely move this pallet forward if this one's out of the way. But notice what's happened. One crashed, but then this one crashed also, and I wanted to avoid this one crashing. So I shouldn't have allowed this one to move forward until this one had completed moving over. So let's make that happen, unless, let's see. Now that seems like it's going to break it, because no, it'll work, because I'm not saying C1003 has to be made, I'm saying it has to not be made. So let's go ahead and put in C1003 and change my wiring just a little bit. I wish somehow they would incorporate the erase tool and the write tool together with the pointer, because I think it would be more efficient. There we go. Okay, so I guess for clarity, let me go here. So now what will happen is we can't actually, even if there's a pallet at, ready to go here, we cannot transfer it over until we know that this is not set, or as long as we know that this is not set. Once C1003 is set, is that what I want? Yeah, this will work, because once this is set, what that means is that I've got a pallet from conveyor 2 that's being processed, or I've got something here. Actually, it wouldn't even matter, right? Because if there's something over here, I do not want to transfer another pallet over. So let's reset and see if that helps me at all. I don't think it's going to fix my problem. I think what I'm going to have to do, let's pause this. Let's download the new version of the code. And once that is downloaded, transfer is complete. Go to run mode. Okay, so now we can unpause. Pause again because I need to hit the start button. Oh, it would help to unpause in order to hit the start button. There we are. So pallet 1 comes through. It'd be nice to see pallet 2 transfer. It did this time. Okay. That's more what I expected before. Maybe the first time I ran it, just pallet from 1 had gone. No, wait a second. I think the pallet from 1 should have gone that time, and it didn't. Well, there it goes. So we are successfully merging. Let's see if we get the same error from before. Ah, that was a problem. We got to fix that. I think the system will clear itself if we manage to turn a conveyor sideways. So I need to figure out why that pallet came forward when it shouldn't have. I thought putting in that bit C1003 would fix that, but it did not. So when that happens again, we will pause, or if the crash from 1 happens, we'll pause as well and debug. I always say that half of programming is writing the program, but the other 100% is debugging, or 75%. Honestly, it seems like it takes twice as long to debug as it does to crank out some code. If you like engineering comic strips, Dilbert by Scott Adams is an excellent strip. It's hilarious. I had a friend who worked at Hewlett-Packard, and he said they would read Dilbert, and it seemed like that there was a mole at Hewlett-Packard because whatever Scott Adams was writing about was exactly what was going on. So there's the stereotypical stupid boss and smart engineers who used reason and logic and so forth, but one of the comic strips was interesting. Well, a lot of them are interesting. They're hilarious, really, and when you become an engineer, you'll appreciate them even more. But one of them was where the boss offered to, and the engineers aren't always ethical. They get sick and tired of things. So anyway, the boss offered to reward employees monetarily for finding bugs in code. So I think it was Dilbert that had Ratbert, which is one of the characters, and this mouse can, or this rat can talk, and the dog can talk, and all that. But suspension of reality, I guess. Anyway, he was talking to Ratbert, and he said, since I can get money for finding bugs in code, why don't you tap dance on my keyboard here, and I'll find a whole lot of bugs, and I'll split the money with you, or I'll make a lot of money. So Ratbert started dancing on the keyboard and said, "Here, how am I doing?" And Dilbert said, "Not so good. You just authored a new web browser." So he wasn't making bugs, he was accidentally creating good code, which obviously doesn't really happen. It takes some intelligence to make code. Even if you use a genetic algorithm, somebody's got to make the genetic algorithm to code that, to make the program. So we're not really getting any more crashes. I don't even recall what change I made last. I know I haven't saved my code, so I'm going to save this as a new version while I watch it work. Save project as. We're on V4 now. Not that I've made a whole lot of changes, but I have fixed some bugs. The nice thing about these emitters is they send the pallets down at random so you can run into problems. The bad thing is they send them at random, so it's not repeatable. It doesn't happen the exact same way every time. Well, while that's running, we'll let it run off to the side. I'm going to make a few more changes because I'd really like the start button to do some things. In fact, one thing that would be nice is if the reset button could reset the sequence. It's very often, if you make a sequence like I've made here, it's pretty often that things happen, you have to stop the machine, and then the sequence is out of step with the real world. There's ghost parts. And so one thing to do, let's see, insert rung before cursor. One thing that's nice to do is to use that reset button to reset all of the, what I call step bits, all the bits that are remembering where you're at in the various sequences. So what I'm going to do is just go ahead and grab the reset button while we're kind of waiting for it to mess up. And I'm going to program it to just reset a whole bunch of things. Now, I can notice that I put those bits in sequence. They were bit 1000 through 1005 or so, I believe. Yeah, 1005. So what I'm going to do, I'm going to use a nice little command that will reset those all at once, I think. Let's see if it'll work. Let's use a copy command. And what we're going to do is copy a 0. Would that work? I was going to say we'll copy it into multiple places, but I don't think it'll accept this. If I say C1000 through C1005, yeah, it doesn't like it because it's trying to copy an integer into this, so that won't work. Never mind, I'll have to do it the long way. So all I will do is make a whole bunch of resets here. I don't know how many I need. I mean, I know I need, what, 6? C1000, but I didn't count how many lines I was drawing. C1001 all the way through 5, so since we started from 0, it's going to be 6 different reset instructions. For C1002, another reset, C1003, C1004. Make sure you're taking breaks while you're watching this video because it's going to be very long, and after a while you just can't focus on what I'm saying. In fact, you may not have even heard what I just said. So let's go ahead and download that to the PLC. It hasn't messed up yet, and it'd be nice to have this functionality, so we'll just change to stop mode. I guess it could have added some other features, but there you go. We'll go back to run. Notice we're in the middle of a sequence, so let's reset the simulator. And now we've got a nice reset button. I guess it would help if I'd press the start button. Also, it'd be nice, one more change I should make is to make it so that the start button actually starts the system. Right now these darn conveyors are just running like crazy. So I'm going to put a condition in that they won't run unless the start button has been pressed. So hopefully this shows you the pitfall of not making a plan. But what we'll do is just add in the start button so that the start light, so that the 2 conveyors don't run unless it's in start mode or in cycle start mode. So these 2 conveyors basically shouldn't run at all. I can just put that condition in here unless the green light's on. So let's see. I'll choose C. No, actually Y. It's an output. And I want the start light. There we go. So it's Y12, and I'll copy and paste it onto the other conveyor as well. We'll save this, I guess, as a new version, even though it's probably haven't made that many changes. And then we'll download it to the PLC and see what we've got. We'll reset this, take it out of pause, transfers complete, go to run mode. And so now we've got a couple of, now we've got a couple of pallets ready to go. Let's hit the start button. And that should allow everything to start. And here we go. There's no timers, so if we can increase the simulation speed, we might be able to get through this a little quicker and get a nice crash. So we run it at twice speed. There we go. Maybe 3 times speed or 4 times speed even. And see if we can get a nice crash to occur. There we go. Ugh. Okay, so I paused it. It was running at 4 times. I should have been ready to go. So unfortunately I missed that one. Let's reset and try again. Now we may be out of sequence, so let's... No, it looks like we're okay. I was going to say we could check our reset button, see if it's working. I need to be quicker on the draw. We'll reset it one more time. Yeah, now we're out of sequence, so now we'll go over and the first thing we'll do is reset. There we go. Well, that should clear it. That should clear all of our bits. Oh, right, yeah. So resetting clears the bits, but I have to also turn off these conveyors. I got to make them go down. So one more change and I'll save it as version 5. Let's see. So when I hit the reset button, there's something else I want to reset. I want to reset the transfer for sure. And I'll reset the loads as well. So let's just go ahead and grab a couple more slots. In fact, for the sake of efficiency, let's just let it restructure it the way it wants. So reset the transfer left 1, transfer left 2. Why did it not do that? Oh, I'm going to finish it. Let's reset transfer left 2. There we go. Let's reset load 1 and load 2, which is the rollers on the transfer conveyors. And we'll make another line and reset. Let's see, load 2. We'll download that to the PLC. Transfer completed. Go to run mode. We go over, hit the start button or cycle start. And there we go. We're away. We're off to the races. And I better be ready, because it crashed pretty quickly the last couple of times. Of course, now that there we go. I was going to say now that I'm ready it won't crash, but it certainly did. So I wonder if what's happening, oh drat, I did not want it to continue. I wonder if what's happening is that the pallet is moving too far forward. No, that's not the case. Well, I mean, apparently it was too far forward, but was it actually moving? Let's reset this, and also reset the PLC. And I really want to see what happens when a crash occurs. I want to know if the pallet was moving forward or not. So let's see, if we unpause, we can reset this if it'll respond. It'd help if I go to a slower speed. There we go. Let's reset the whole thing. Reset the sequencer. Okay, so that should be good. Now we should have pallets coming through and working again. Yep, there comes 1 from 2. That's good. There comes 1. I don't know why it didn't go. Maybe we're a bit out of sequence. Well, no, I reset the sequences. There we go. So now let's speed things up and be ready for a pause. I bet this one's going to be problematic. Look at that. The pallet is too far forward. And when I unpause, I bet this one's going to hit. I bet I just figured out or I just observed what's going on. Let's turn this off and let's watch it. In fact, let's watch it in slow motion. So let's unpause. Sure enough, there it is. Somehow, the pallets from conveyor 1 are coming too far forward. And when that happens, there's a crash. So it's as if it's decided to send the pallet in, but it stops for some reason. Let's see if we can see where we're at in the sequence for conveyor 1. Let's see. Or for processing a pallet from conveyor 1. So process pallet from conveyor 1 sequence. 1004 is reset, 1005 is reset. So we're not in that. We're not actually. We haven't started that sequence. So it's not the sequencer that managed to move the pallet too far forward. Something turned it on. Now my guess is that something turned on conveyor 1 that shouldn't have. Let's see, so conveyor 1, if there was some way that these conditions were true, or if there's some way that at entry 1 dropped, then the inverse of false would be true and power to get through here and the conveyor would come on. I don't know what happened. Unfortunately, I'm going to have to reset and get over here and reset the sequencer at the controls. Hopefully I can reach it. All the sequencers should be reset. Yeah, we don't have a pallet yet. And what I'll have to do is observe that rung when I notice that a pallet's starting to go too far forward. So here we go. That's the right position. I like that. Okay, no, that one went through. That's good. That one went too far forward. So I missed it again. Unfortunately, I don't know if I'll be able to debug this, at least not on the video. It's just getting to be too long. The overall approach I've taken is not an approach that I am fond of. I prefer to actually set out my sequences in Excel and figure out exactly what the inputs are going to do and what the outputs should do. And a lot of times little problems like this will be avoided if I did it that way. Now, I didn't do it that way for two reasons. Number one, students don't tend to like starting that way. Students like to just jump in and start programming and get the job done. And that's usually not a good way to do it. It's much better to do a little bit of planning. One of the difficulties, I think, is that students don't understand the simulation, or they don't understand the machine. And really, you've got to understand the machine before you start programming. And I really like the Factory I/O simulator because you can bring up the, you can dock all the tags and you can force things. You can make conveyors move. You can make stuff happen and see how it works and know what you want your PLC to actually do. So what I'll do is a little more debugging on this. I'll find what the error is and I'll fix it. And then I'll just maybe make another video. I'll just tell you in class what I found that made this work properly. But something's happening, obviously, where the pallet's going too far forward. But I think I'm out of time to explain it now. So I'll find it and maybe add to this later or just tell you in class.